So, intercepts of lines. This is going to be kind of our simple way to introduce things before we get into actual slope with stuff, actual point in the line, and all this other fancy stuff. So we talked a little bit back on Monday on how this whole thing works with an x or y intercept. A couple of things to make mention of. With an x-intercept, okay, the point where the line crosses the x-axis. On an x-intercept, y is always going to be 0. So, for instance, that point that I've drawn an arrow to right now, what we're going to do is we are going to make that point the y value 0, because here's my y-axis. Gentlemen, again, whether you choose to work or not, that's one thing. Talking a little lessons, that's not one of the options we got. And I look to see where the x value is when it's crossing the axis. And since it's here at negative 3, I just put that in with it. My intercepts are always going to be coordinate ones, okay? But with an x-intercept, this value will always be 0. With y, it's just the opposite. My x value is always going to be 0. Because to get here, I don't move left or right at all, I just go up 2. So my y-intercept in this case would be at 0, okay, negative 2. This is negative c. What's that? Did I say, I'm sorry, 0, 2. Thank you for the correction on that one. So, whenever I'm looking for these on any line, I'm just going to continue to keep looking for my intercepts. So, for instance, on number 1 down here below, and here's my x-axis. I'm going this way. Where does the line cross the x-axis at? 2. So my x-intercept would be 2, 0. Again, when it's the x-intercept, y is always 0. However, my y-axis goes up and down. Where does my line cross negative 2? So 0, negative 2 would be my intercept. So let's just say, for instance, we were taking a look at number 2. What would be my coordinate point for the x-intercept? Where's the line cross the x-axis at? It crosses at 3. Excuse me. What's that? Y-intercept or x-intercept. Yeah, sorry, I'm trying to kind of shorten it up a little bit. So that's one of the things that we're going to do. So, what about the y-intercept? Where's the line cross the y-axis at? Where's my dot on the line when it crosses y? 4. So again, the y value is the second one. Just like in the alphabet, you have x and then y. It's the same thing with the coordinate point. X is always going to come before y does. Now, they may not always give me a picture that they want me to find the intercepts from. May not quite always be that simple. So if we move up a little, they may even be nasty enough that they give us a line and they don't put the dots on it. So if they do that, it's going to be our job to put the points in ourselves. So if that's the case, where's my x value for my x-intercept? Thought I heard it. At 3. So I put 3 in the x place, put 0 in the one that I don't need quite yet. So what about y then? 4. And again, the 4 goes in the y spot, the 0 is going to go in the other one. If they give me a chart, again, all I have to do, I see the 0 in the y spot, that's my x-intercept. If I see the 0 in the x spot, that's my y-intercept. But I've always got to look for where the zeros are going to be. Good question. Okay, let's look at it in a graph, in a picture way, and that might explain it a little better. So let's say, here, we said that my x is crossing at 3 here. Do I have to go, if I started here at 0, 0, I go right 3. Do I have to go up or down any? No. My y value, since I didn't go up or down, is at 0, since I didn't have to go any direction for that. And then for y, it's just the opposite, since I don't have to go left or right. Oh, now that'd be totally different, because 3 and 4 would be like over here somewhere. Because I will have somebody that tries that. But yeah, they've got to be separate. You always got to have 0 with one of them, just so we can signify that. It could be. It could be. If you have a line that goes right through the origin, it could be. So again, just keep looking for those zeros. The zeros in y, that's your x-intercept. If your zeros in x, that's your y-intercept. And just kind of keep going back and forth with them. Then the last part is going along with what we started on Monday. If I'm trying to calculate this, I want to graph them, but I also want to figure out what the intercepts are. So remember, hopefully, how we're going to do this. For x, we're going to cover up y and pretend it doesn't exist. Whatever equation that I have left, in this case, x equals 3. Oh, that's nice. 3, 0. I don't have to even solve for x. It's already done. So whichever variable you're looking for, you just cover up the other one. So if I'm looking for y, I cover up the x part. But this one's a little different, because I don't have the y by itself yet. What's my one step to get y alone? If I'm multiplying side by -1. And once I have my 2 points, -3. I can plot my 2 points, bless you, and draw that through. But whenever I'm looking for x or y, all I'm going to be doing is kind of writing through on me what's going on. So for instance, when I get to 9, if I want to know what x is, I cover up y. Thank you. So 10x equals 20. Again, I just make the other variable disappear. What's my one step to get x alone? Divide by 10. I get my point. X is 2. You even could go so far if you wanted to. So when I go to do y, let's say, if 5y equals 20, I don't even mind if you even left it as 4. Because I know that at that point, you're like, okay, if my y value is 4, that's up 4. If my x value is 2, here's my x-axis, that's right 2. And I'm just going to draw the line through it. So it's not really that kind of horrible of a process. It's just more or less getting used to it. Now, instead of painting you through all the rest of these in the back, I'm going to do number 10. Then I'm going to give you an option, which I think you'll like the option, but we'll see. All right, last one here on the front. Cover up y since I'm looking for x. If 4x equals 8, what's x going to be? 2. Okay, put a dot where x equals 2. Switch them up. If negative 2y equals 8, so I covered the x, I'm not looking for the x. And divide by negative 2, y is going to be negative 4, which is down. And then I draw my line through. So, even though this is a note sheet, here comes extra credit opportunity number 1. If you choose to finish the problems on the back of the note sheet, you can have extra credit for doing so. On top of that, when we get to the quiz that has to do with Intercepts, we can use this sheet. So this isn't going to be bad. It's not bad. It's easy points. Okay? Now, you know how I've been with all this stuff. You're like, oh wait, he says this is a note sheet. We know what's coming next then. What it means is, the other, on the back of this sheet you just got, it's just like what we just got done doing for the last 3 problems. Now, we're going to change the directions though. Because this says, write it in slope-intercept form. No, we are going to find the intercepts. We're going to keep doing what we've been doing. Now, here's how this is going to work. I want to take a look. I'll look at 10, maybe we'll do 11 too here. So when I'm doing these, I need the x-intercept, and I need the y. I need the 2 points. So again, if I'm looking for x, cover up y, and I solve that equation. If I cover up y, what I see left is I see 2x on the left, and I see 1 on the right. What's my one step to get x by itself? Okay, just divide by 2. You're like, wait a minute though, that's like a decimal. That's like 1/2, or it's like 0.5. What's up with that? That's not a big deal. Because what I can look at, okay, here's my y-axis, here's my x. Okay, x is 0.5. It's just between 0 and 1. So I can still do it. It doesn't have to be perfect on the decimal, but I can get in the approximate area. For my y-intercept, I cover up x. Oh, y equals 1. That one's done already. Y equals 1. Draw my line through, and if I did it right, it should go through a letter. So this one went through n. Okay. And that's basically what we're going to do on this whole part. Now I'm going to do 11 too. Then I'm going to start introducing something to you a little bit today before we actually do a lesson on it. So one more time. X-intercept. You can just try to write x and y. That's fine. Okay. X-intercept. Cover up y. Like, all right, negative 3x equals negative 4. You're kind of starting to catch on here. It's always that same one step. What's my one step here to get x by itself? Okay, divide by negative 3. And again, don't let the fact that you get a decimal mess you up. Okay, 1.33. I can do 1.33. Just going to remark my axes here. So 1.33 is a little more than 1. My dot on my x-axis. Once I put my dot, I switch. I cover up the x. I write what I see, 2y equals negative 4, and I do the same one step. I divide. Y is negative 2. Down. All line, sweet, goes through a letter, T. So that's all we're doing. X-intercept can cover up the Y. Y-intercept can cover up the X. Make money from Office X and advertising for it now on YouTube. So that's what we're looking at here on the back. On the front side, you're like, ooh, this looks a little different. Solve for Y. What? In other words, get Y on a side by itself. And that's what's going to work the whole way down on this one. So for instance, in number 1, if I want to get Y by itself, how do I get the 2X out of there? Minus it. And sometimes it'll be as simple as one step. Now here's where I got to be careful though. When I come over here, this has X, this doesn't. I can't put these together and call this 10X. That doesn't work. I put the X part first, then the number. And I need to do it that way, because this is going to be something we're going to work on here in a few days called slope-intercept form, where it's Y equals, and then the X, and then the number. So I'm going to bounce around a little here. I want to take a look at 3. I want to take a look at 9, and we might have another one in there too. So on number 3, my first job is to get the 2Y alone. How do I dump X? Minus it, it's positive, good. So we're like, okay, so that goes away. And if I see no number in front of my X, I assume there's a 1. And just like on the first one, this has X, this doesn't. I can't combine them. They can hang out on the same side of the equation, but they can't be together. But this time I'm not quite done yet, because Y is not totally alone. One step left. Okay, divide by 2. Oh, I'm hearing video noises again that I shouldn't be hearing. Okay, if it stays in a fraction form and doesn't reduce, just leave it as a fraction. Try to stay away from decimals here, because I really don't want to see 0.5x. But 8 divided by 2 is 4, and Y is alone. So again, don't let anything kind of mess with you here. It's going to be the same step or 2 steps for every single one. One last one here, 9, unless somebody finds one they want me to play with. Ooh, I see. One I want to play with. I want to play number 9 at the bottom, too. So number 9 up here at the top, just keep telling yourself, solve for Y. Must get Y alone. Positive 5x, just like we did on number 3, we're going to minus that. Then I got to give myself one more reminder. Oh yeah, I can't combine these. This is not 5x. Keep them separate, kind of work through them that way. And then my last step will always be to divide if I need it. And we just kind of get to reinforce here. If I punch 5 divided by 2 in my calculator, I get a decimal. I don't want no decimal. So I'm just going to rewrite it. Ooh, but what's 10 divided by 2? Okay, negative 5. Negative 2. Okay, Y is by itself, I'm done. So at most it's going to be 2 steps. Sometimes it's only going to be 1. Except for the one exception, of course. Sure, this one? Okay. Want to get that by itself. How do I get 4x out of there? Not dividing quite yet. No, we're not going to divide it, because remember, the only time we divide is whatever number's with Y. Okay, let's chat about a couple things here. Let's finish up this one, and then I'm going to have a different start to the next one. Let's see if that works better for you. So the X and the 9 can hang out on the same side, but they can't be together. And then since I still have that negative 1 that's attached to my Y, I'm going to divide everything by that number. Because I have to get Y positive and by itself. Negative divided by negative, and I'm going to do another one here too in a minute, is positive. Positive. y equals 4x minus 9. My whole job here is to get y alone. So let me kind of put it this way. Let me pull this down for a second. When you're solving for y, two steps. One, I'm either going to add or subtract my x term. So if there's an x there with the y, I got to plus or minus that out of there. Perfect. And then I'm going to divide by whatever number's in front of y. It's always those two steps. That's not going to change on me. Okay? But like I said, there's one exception. Just one. Way at the bottom of this page, on the second number 9 on this side. And then again, if there's some other ones you want to take a peek at, I'll be happy to do it for you. You're like, ooh, okay, here's my y, but now I got x's and numbers over here. What's the deal? Well, I got one extra step I got to do. I got to get the number to the other side, because I don't want it hanging out with y. Right. Now I can do my steps. Now I can, in this case, minus my x out of there. Yep, and I just got to keep reminding myself, I can't combine the x with the part that doesn't have an x. They don't quite mingle. And if I divide by 2, when I go to the calculator, if I get a decimal, I'm just leaving it. So I'm leaving the negative 7/2. I'm leaving the 3/2. And I'm done. So that's what I'm up to on this half. Get the y term by itself, and if there's a number with y, I divide by that. That's never, never, ever going to change. Any other ones that look kind of ink that we want to take a peek at here? I'm absolutely willing. Oh, it was low. Okay. Again,